Alright, so this video is going to be part 3 of our alternating series test practice. So we want to determine if this series converges or diverges, and we have the sum up on the board, or the series up on the board, the sum from n equals 1 to infinity of sine of 2n minus 1 times pi over 2. Now this series itself is not, we don't need to perform an alternating series test on this, but it does relate. Okay, so you notice we have a trig function with a bunch of weird stuff in it. Okay, and you know, you're probably wondering, okay, what is this even talking about here? Well, if you start actually plugging in here, okay, we plug in 1, we get sine of 2 times 1, that's 2. 2 minus 1 is 1, so you get pi over 2. Okay, that's your first term. Your first term is sine of pi over 2. Okay, what would be your next term? Well, you plug in 2, you get 2 times 2, that's 4, minus 1 is 3, 3 pi over 2. Okay, so you get plus sine of 3 pi over 2. Next, if you plugged in n equals 3, well, you're going to get a sine of 2 times 3 is 6, minus 1 is 5, 5 pi over 2. Alright, and that's just going to keep going. Alright, and what you're seeing here is this is just 1, sine of 3 pi over 2, that's minus 1, okay, that's negative 1, and sine of 5 pi over 2, same thing as sine of pi over 2, that's plus 1, okay, so you're going to keep, it's going to be 1, minus 1, plus 1, and it's just going to keep going, minus 1, plus 1, minus 1, plus 1, okay, and this is an alternating series, but you don't need to use alternating series test for this, okay. You can just simply solve this with the test for divergence, okay? You see that the limit as n approaches infinity does not equal 0, okay? Of, actually, we can put in here, of sine of 2n minus 1 times pi over 2. That doesn't equal 0 because this is just alternating between 1 and negative 1. Okay, so it's not going to converge to anything, therefore it diverges. Okay, so it diverges by the test for divergence, but what the point of this whole problem is that there's other things other than a negative 1 to the n minus 1 or things like that that can make an alternating series happen. Okay, for instance, this, okay, if you have a trig function or something like that. So that's another thing to check for, especially when you have a trig function with a large thing inside of it. Okay, then you know that might be something that you're looking at is in alternating series. Okay, so that's it for this problem. Now for this series here, we again have that sine of 2n minus 1 times pi over 2, but now we have a 1 over n in front. Okay, so now this is an alternating series test problem. What you're going to see here is that, well, this is just the alternating harmonic series, okay? But instead of having that negative 1 to the n minus 1 or negative 1 to the n, okay, now you have another thing, which is sine of 2n minus 1 times pi over 2, okay? And that's another thing that's that's another thing that can make a series alternating, okay? So again, we have the alternating harmonic series. So we got to see if it's decreasing. All right, and what do we have to see is decreasing? Well, we don't care about this part at all. We don't care about that alternating part. We care about our b sub n, which is the part that of this whole series that is not alternating, which is that 1 over n. That's what we have to see is decreasing. And is it? Well, yeah, of course, as n gets bigger and bigger, this becomes a smaller fraction. So, yes, it is decreasing. Now, is the limit as n approaches infinity of that b sub n equal to 0? Well, of course, the limit as n approaches infinity of 1 over n, well, yeah, of course, we already know that's equal to 0. So, this is convergent by the alternating series test. Alright, so really, nothing too crazy here, but just be on the lookout for something else that can make a series alternating, okay? That's really the whole point of this video, and that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the alternating series test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.